Today we're going to be talking about applications of exponential and logarithmic equations. By the end of this video, you should be able to use exponential equations to solve real-world problems. First, let's go over some vocabulary. Most of our examples today are related to finances, so we need to understand financial vocabulary. Principal is the original amount of a loan or investment. Interest is a charge for a loan, usually written as a percentage. It's calculated as a percent of the principal. Value is how much something is worth. Depreciate means to decrease in value. Now, the next few words, you probably know what they mean, but not necessarily in this context. Annually means once a year. Semi-annually is twice a year. Quarterly is 4 times per year. Monthly would be 12 times per year. Daily is 365 times per year. And continuously means occurring at every moment. Now, we have 3 different formulas that we're going to take a look at, and we'll look at a couple examples for each formula. The first one is the appreciation or depreciation formula. It is V sub t equals A times 1 plus or minus R to the t, where A is the initial value, R is the rate as a decimal, T is time in years, and V sub t is the final value. Now, usually when we see plus or minus, we have 2 answers, but in this case, it's just giving us one formula for 2 different scenarios. We would use the plus when something is increasing in value or appreciating, and you use the minus when something decreases in value or depreciates. So the first problem says, a car was purchased for $90,000 in 1995. If the value of the car depreciates by 5% each year, what will it be worth in the year 2020? So depreciates tells us we're going to use the minus in the formula. 90,000 is the initial value, that's how much it was worth at the beginning. If it depreciates by 5%, we want the rate as a decimal, which would be 0.05. And then we need to know t. So from 1995 to 2020, that's 25 years. and we want to find the final value. So we just go ahead and plug our numbers in. And then just type this in the calculator. 90,000 times 1 minus 0.05 to the 25th power. And since we're dealing with money, we're going to round to 2 decimal places and make sure you put the dollar sign out front. So our final value is $24,965.06. Let's look at another example. A house was purchased for $175,000. After 20 years, it is now worth $250,000. At what rate was the value of the house increasing? So we know that originally the house was $175,000, so that is A, our initial value. We're looking at a time span of 20 years, so that's T. Now it is worth $250,000, so that will be VT. We are trying to find R. Now, it says increasing, so we know we're going to use the plus version of the formula. So let's plug our numbers in. So if we want to solve for R, first we need to divide both sides by 175,000. We end up with 10 over 7 equals 1 plus R to the 20. To get rid of the 20th power, we need to take the 20th root of both sides. Then to finish solving, we need to subtract 1 from both sides. Now we can grab our calculators and figure out what this equals. To type in the 20th root, you go to Math, then number 5, and it lets you type 20 as your index. And make sure you type the -1 outside of the radical. So this would give me 0.0178. So if that is our rate, that's the decimal version. So if I move the decimal 2 places, I end up with 1.78%. Let's look at the next formula. This is the compound interest formula. P is our principal. R is the rate as a decimal. T is time in years. N is the number of times it is compounded per year. And A is the final amount. So you know that you're going to use this formula if you see compounded annually, semi-annually, quarterly, monthly, weekly, daily, any of those words on the first part of the notes except continuously. Continuously has its own formula. So let's take a look at this first example. You deposit $1,000 into a bank account that pays 8% annual interest. Find the balance after 10 years if the interest is compounded semi-annually. So 1,000 is going to be our principal. That's how much we started with. 8% is our rate, so we're going to use 0.08 for R. We're looking at the balance after 10 years, so that's T. And the interest is compounded semi-annually. So at the beginning of the notes, we said that semi-annually means twice a year. So for this, N will equal 2. So let's plug everything in. Now we can just type everything in the calculator. We have 1,000 times 1 plus, I'm going to use my fraction button, 0.08 over 2 to the 2 times 10. So I would end up with $2,191.12. And don't forget to put your dollar sign. Let's look at the next example. You have an account that pays 4.5% annual interest compounded monthly. How long will it take for your investment to double? So it tells us that R will be 0.045. Compounded monthly means the N is 12. And it doesn't tell us anything else. It doesn't tell us how much money we invested. It just tells us that we want to look at how long it'll take for our investment to double. So I'm going to assume that I put in $1. And if it doubles, then the final value would be $2. And you can pick any number that you want for this, but using 1 and 2 is the simplest way to do this. Then I'll plug everything in. And I'm trying to figure out what T is. So if I type the part inside the parentheses in the calculator, I end up with 1.00375. Here's where the logarithms come in. Since I'm trying to solve for a variable that's in the exponent, I need to switch this to be a logarithm. So I have log base 1.00375 of 2 equals 12t. Then I just divide by 12. Then you can type it in the calculator to get the final answer. I go to math, log base 1.00375 2. Then I want to divide by 12. So I get that T would be about 15.43 years. Let's look at one more formula. This is the continuous compounding formula. If it says the phrase compounded continuously, then you know this is the formula you need to use. Here, P is our principal. E is the irrational constant, E. R is the rate as a decimal. T is your time in years. And A is the final amount. If you deposit $1,200 into an account that pays 5% annual interest. After 10 years, you withdraw the money. Find the balance if the interest is compounded continuously. So $1,200 is your principal. It says 5%, so that means R is 0.05, and you're looking at 10 years. So let's plug this in. So to type this in the calculator, we do 1,200. Oops. To get E, you do second natural log, then you type the exponent. So we end up with $1,978.47. One more example. If you want an investment to grow from $50 to $500 in an account with interest compounding continuously for 20 years, what would the interest rate on the account need to be? So 50 is our principal, 500 is our final value, and we're looking at 20 years. We're trying to find the rate. So first we need to divide both sides by 50. We get 10 equals e to the 20r. Then we need to convert to a logarithm, and since we have e, we use natural log of 10 equals 20r. So r equals natural log of 10 divided by 20. If you type this in your calculator, you get that r equals 0.1151, which means that r would be 11.51%.